Hi all, so in the previous video we looked into the basic definitions of what you mean by velocity, what you mean by acceleration, what do you mean by displacement and its corresponding terminologies. For solving a problem, you need to have some basic equations. All those equations are more than enough to solve a problem that is required for engineering mechanics. So without any delay, we'll get to the equations. So these are the three basic equations. Basically, you can find four equations, but these two terms are basically can be combined, are just one and the same. Okay, so these are the these are the equations that are very necessary to solve a particular problem. Okay, so the first one is V is equal to U plus AT, which means V corresponds to the final velocity, and obviously you know that U corresponds to the initial velocity, A corresponds to the acceleration of the body, and T corresponds to the time taken. Basically, this time taken is where it starts from U and it ends with V. So this is the time taken that is present in this equation. So V is equal to U plus AT. Another equation that is very important, so consider this as equation 1. Another equation that is very important is this one. S is equal to ut plus half at square, right? Obviously here S corresponds to your displacement, right? And u is your initial velocity, t is the time taken, and half, obviously it is a constant, and a corresponds to acceleration, t again reappears. Over here, please note the point, this particular t corresponds to the time taken, which means time taken for a body which has initial velocity u and it reaches the final velocity v, whereas this particular t corresponds to the time taken to complete displacement. Yes, okay, so this is very important. Both these time, of course it is referred as time taken, but this particular time which appears over here is the time taken for the body to have an initial velocity and then ends with the final velocity, whereas this particular time taken is a little bit different. For completing a distance, what is the time taken, that has to be considered, and the final one is v square plus v square is equal to u square plus 2as. So this becomes the third most important equation. Okay, so without no further delay, we'll get back into the, or we'll get into the problem. Okay, so here we have a problem. So it goes like this: a motor car takes 10 seconds to cover 30 distance and 12 seconds to cover 42 meters. Find the uniform acceleration of the car and its velocity at the end of 15 seconds. Okay, so without any delay, we'll see how it is getting solved, right? Fine. So first we'll start with this very simple equation. S is equal to ut plus half at square. Fine. Why this equation is taken into consideration? Look into this. Here 10 seconds, which means you have a time. Here again you have a distance. Yes. Here again you have a time, and here again what you have is S. You are asked to find out what is your acceleration and what is your velocity, and again they have given you what is your time. Fine. So we look into the basic three equations that we have come across. One such equation is v square is equal to u square plus 2as. If you consider this particular equation, v square is not known to us, u square again it is not known to us, a not known to us, whereas only term that is known is s. Okay, so this is the only term s which is known to us. So if you take this equation, obviously you have three unknowns. So you cannot solve this and find out the value. Sorry for making a spelling mistake, but you have 3 unknowns over here. You cannot solve this. Then you have this particular equation, v is equal to u plus t. So again, if you consider this, v is not known to us, u is not known to us, a is not known to us, only t is known. Here also you have 3 unknowns, which means this equation also cannot be used. So the last equation, which is s is equal to ut plus half a t square. So this equation, obviously this is known to us, this somehow we can try to manage it, whereas the time is known to us, and acceleration again is what you have to find. So this equation is much better if we try to use it. Okay, right. So first condition, okay, sorry. So first you have, when t1 is equal to 10, the distance covered is s1, which is 30. When you have t2 as 12 seconds, obviously the distance s2 is equal to 30. Okay, so if you are trying to solve this particular problem, here in this equation substitute t1 s1 and t2 s2 separately. Okay, so we have solved, or we have just substituted what is the value. So this equation is where we have substituted t1 and s1. So this 30 is taken from this particular value, distance is 30, u again it is not known to us, t is known, which is 10. Okay, so this particular t1 10 seconds plus half, a is not known, whereas again the time is known to us. So this you can take it as equation 1. Let me just simplify this. If you simplify this, this is the equation that you are going to get it. Okay, so this again take it as equation 1. Next, substitute t2 and s2. So if you substitute it, obviously this is what you're going to get. So this is this particular condition. So s2, I'm sorry, here I made a very big mistake. s2 is 42. You can check it over here. s2 is 42 meters. We have substituted 42 meters. Time is 12 seconds, which we have substituted from this, half at square. Again, you can simplify this. Here, this is what you will be getting, equation number 2. So now you have two equations. So the first equation is where you have 30 is equal to 10u plus 50a. So second equation is 42 is equal to 12u plus 72a. So use these two equations and solve it. Obviously, you are going to have your value of u as well as your value of a. Okay, so when you are solving equation 1 and 2, you are going to have the acceleration as 0.5 meter per second square and velocity is 0.5 meter per second. Okay, now they have asked us what is the velocity at the end of 15 seconds. Okay, so now they are asking us a velocity. Let's just keep it as simple as this. Okay, the acceleration value is known to us, initial velocity is known to us, time is known to us. So which means we can use this equation, v is equal to u plus at. U, you can find it over here. Acceleration is also known, time is 15 seconds over here. You substitute it, we are going to get what is the value of your final velocity. Okay, so once a problem is given to us, first what we have to look is what are the values that are known to us, then the three basic equations has to be recollected, then it will be very easy for solving a